So we come to the liquid state. We just saw that there is hardly any difference between the gaseous state and the liquid state, except for the closeness of the particles due to predominance of intermolecular forces. Right. So the first thing is that due to high intermolecular attractive forces, the particles are close together. Okay. How close? So close that if you try to compress it any further, it resists you. It is at the optimum distance. Okay. So much so that the liquid is almost incompressible. Okay. They are very incompressible. Fine. What is low? Z. Z is not for liquids. Don't mistake it for liquid. It's a gaseous equation. It is applicable for gases. Okay. So the concept of Z does not apply here, but the concept of bulk modulus comes into play. That you'll come to understand later. And inverse of the bulk modulus is compressibility. So the bulk modulus is so high that the compressibility is very less. Okay, there is a concept of bulk modulus in physics, which we'll do. So it is incompressible. The next thing is that the molecules are so close to each other, the particles are so close to each other that if you say remove or put it in an open space, it does not kind of vaporize or kind of move away from each other to occupy the whole volume. So the particles are so close and attached to each other the particles are so close and attached to each other that the volume of the liquid remains a constant. Okay, so the volume of the liquid remains a constant. Now that is the beauty of this. See, they are close together, they are held by each other so that they remain as a bulk, right? Okay, they remain as a bulk. You pour it from a say a beaker into a jar, it remains, the volume remains the same. So they are attached to each other. They are not letting the molecules escape. But they are not so attached as to be as rigid as a solid. Okay. The particles are free to glide past each other, are free to glide past each other so that the liquid can flow. So that the liquid can actually flow. Okay? It can flow. It can flow like a gas. Not in the sense that the particles are in random motion. I'm not saying that. though there is some amount of random motion. Let us be clear about it. That is what you call the Brownian motion. You put a drop of ink, you see it getting diffused in so many directions, and that is what the Brownian motion is it not? That's what the random motion is. So it is free, not as free as the gaseous particles. Correct. So it's no wonder that it acts as a borderline between the gas on one side and the solid on the other. Right. So that the liquid can flow, it can be poured from one, it can be poured from one container to another. Okay. This is because the layers of liquid glide over one another. And this property is denoted by viscosity. Okay, so you take water, okay, you just keep a thin glass plate over it and pull the plate, the plate will get pulled easily. Okay, not as easily as you would have been able to pull it in a gas. You put it on a honey and you try to pull it, it will stick. Okay, it seems it is not moving, or a considerably more amount of force is required. So what is happening? One of the layers of the liquids, the layer of the liquid is holding tight onto the other layer. Okay, so it is holding tight onto the other layer. This is the other layer, right? This is the layer. We will study more about it in mechanics of fluids, that these layers are called streamlines. You can actually see them. You can actually see those layers gliding past one another. Okay, so maybe at one point you put some blue ink and another point you put some red ink, and you'll find them just moving without crisscrossing each other. That is the kind of flow which is called a streamline flow. So during a streamline flow, okay, which is before the turbulence sets in. Hold on. Which is before the turbulence sets in, it glides like that, and there are so many layers. Okay, so I have drawn only maybe two, and this is the third. Okay, so okay, so they glide past each other, and more freely are they able to glide past each other, less is their viscosity. More freely can they glide past each other, lesser is the viscosity. We'll deal about it later. In a few videos we'll come to that. Okay, so that is what a liquid is. Okay, not as free as a gas, but not as rigid as a solid, hence forming a boundary between the two. Correct.